here, right? So how do we find the domain, or how do we find that when the denominator is 0? We just take the denominator, in this case is x plus 3, denominator. We say, okay, x plus 3, if we want to find the domain, we would put a not equal sign, right? We would put slashes through this equal sign. Then we would get x not equal to -3. So we see the domain of the rational function is x can be any value but -3. So how do we use the interval notation? So using interval notation, we go from negative infinity. Let me find the infinity sign. So I go insert, I go special characters, I type in infinity. You see the sign comes up. Right? So I need 2 of them. So let me just copy 2. I close it. So from negative infinity up to -3, then open parentheses with union -3 up to past infinity, right? So this is how we get rid of -3 in the set. So we're splitting into 2 open sets, right? You see in 2 open sets, negative infinity up to -3. So -3 is not in this open interval. And also -3 up to infinity, -3 is not in this open interval. So this means exactly x can be any value but -3. So the interval notation is this. Anyone has any questions? Yes, Ajeta.
Good afternoon, Professor. Can you hear me?
Good afternoon. Yes.
Quick question. So because
Yeah.
it can't be -3, wouldn't it only go up to the negative before it or after it, and not
Now,
negative?
what is it? Can you tell me? That's a very good question. But let me ask you this: what is the number before -3? No one can tell, because there are infinitely many irrational numbers.
Mm-hmm.
Yeah, that's why we use open interval. We use this close parenthesis, which is open interval. Open interval not including -3, but including any number close to -3. That's a trick.
Understood.
Okay. Let's see next one. The denominator is x minus 5. So we just say, okay, x minus 5 cannot be 0, or x cannot be 5, right? We see the domain is x not equal to 5. Use the interval notation. Negative infinity, I'm going to copy here. Negative infinity up to 5. Then 5 up to positive infinity. Okay, this is how we get rid of 5 in the set. Because this set does not include 5. This set does not include 5. This set including any number on the left-hand side of 5. You could think like a 4.99999, millions of nines follow. Right? And this set including a number very close to 5, but a little bit bigger than 5. You could think of 5.00000 millions of zeros than 1. Same thing for this one. We take the denominator 2x plus 3. We say, okay, that cannot be 0. Then we solve. That means x cannot be -3 over 2. We use the interval notation. Let me actually copy paste. But this becomes -3 halves. -3 halves. So x can be any number in this function, but -3 over 2. Because 2x times -3 over 2 give us -3. -3 plus 3 will be 0. It will cause 0 in the denominator. That's a linear denominator, right? Now let's go to quadratic denominators. Let's see we have this rational function. The quadratic in the denominator is factored. So how do we find the domain? We do the same thing. We take the denominator, we see that cannot be 0. That cannot be 0. Then we solve for each one. Then we see x cannot be 2 or -6. So we use the interval notation. See, x can go to -infinity up to -6, union -6 up to 2, not to infinity yet, up to 2, then union 2 up to positive infinity. You see, in this case, we get rid of -6. -6 is not in the set, and 2 is not in the set. So two values not in the domain of this function, -6 and 2. Anyone has any questions? But this is just by convention, okay, by what people agreed upon. So we all read this way, so we understood each other. What do we mean? Well, let's see this one. Denominator is quadratic, obviously, right? X squared minus 2x plus 1. And we said this one saying that cannot be 0. Then we put in the factor form, there's x minus 1 squared. That cannot be 0. That means x cannot be 1. Okay, we use interval notation. Before was set notation. Let's use interval notation. Negative infinity up to 1, and 1 up to positive infinity. Let's see the next one. Denominator is 2x squared plus 3x minus 5. Right. And if we don't know how to factor this, we can put it into quadratic formula. Okay, negative b plus minus square root b squared minus 4ac, all divided by 2a. Right? A is the number before x squared, b is the number before x, c is the constant, the number itself. And this one, if we know how to factor, we can factor this way. And we set to be 0. Then we use 0 property to see, okay, the first factor can be 0. If this one is 0, x equals -5/2. Or this one can be 0. Right? X minus 1 equals 0. That means x equals 1. So again, we have two numbers are not in the domain of this function, -5/2 and 1. And those two values will cause the denominator to be 0. Anyone has any question? Okay, we care about simplifying expressions whenever we could. If we have 4b over 5b, we would rather write as 5/4, 4/5. Why? Because b divided by b is 1. Something divides itself is 1. Let's see. If we have x plus 3 over x minus 4, this one we could write, we could split the numerators. We can write as x over x minus 4 plus 3 over x minus 4. Or the other way around. You have two fractions with same denominator, we just perform the operation in terms of the numerators. Now let's see if we have this, x plus 3, x minus 4 divided by x minus 4. This one can be thought as this, x minus 3, then x minus 4 divided by x minus 4, which is 1. So left with x minus 3. Oh, hold on, this is plus 3. Let me change this one to be minus 3. Now it's consistent. a term is called equivalent fractions. Means if we simplify the fraction to its simplest form, they have the same form, like 2/3 and 4/6. Right? 4/6 can be simplified to be 2/3. 2/3, there are many, infinitely many equivalent fractions, right? 4/6, we multiply 2/2, right? Then 3, no, not 3, 2, 1, 2, 3, there'll be 6, 6/9, right? Multiply 2/3 by 3/3, then by 4/4, 4 times 2, that's 8, 3 times 4, that's 12, so on and so forth, like infinitely many, okay? Infinitely many. So basically, you multiply the numerator and the denominator with the same number and operation. Let's say this case, if A, B, C are numbers, where B is not 0, C is not 0, because they are going to appear in the denominator, so we force them not to be 0. Then AC/BC equals to A/B. Or the other way around, A/B equals to AC/BC. AC/BC equals to A/B. Okay, sometimes we have rational expression that we can simplify also. Let's see this rational expression. The numerator will have two factors, x plus 3, x minus 4. The denominator will only have one factor, x minus 4. So this can be written as x plus 3 times, let me write one more time of this. Right. Because x plus 3 is in the numerator, so we can write on the side. Then we see x minus 4 divides itself, that becomes 1. Right? That becomes 1. So that's why this one can be simplified as x plus 3. And that's it. Number 2, x plus 5 cube. That means x plus 5 times x plus 5 times x plus 5. Then we can simplify one factor with the numerator. That's okay. Yeah, if you have a problem with your browser, just try your best. So we see this one, we could do the calculation, right? Or we see the numerator will have x plus 5 raised by 1. The denominator will have x plus 5 raised by 3. So let's just cancel out of 1 x plus 5, it becomes 1 over x plus 5 squared. Let's see this one. Everything is in a factored form. Right? We just have to simplify it. X minus 1 squared over x minus 1. That simplifies to be x minus 1. Then x minus 4 over x minus 4 cube. That simplifies 1x minus 4. So that's x minus 4 squared in the denominator. So the answer is x minus 1 divided by x minus 4 squared. Anyone has any question? Let's see next one. x squared plus 5x plus 6 divided by x squared plus 8x plus 12. We want to put them in a factor form to see if it's possible to cancel out some factors. Indeed, we factor the numerator, we'll get x plus 2, x plus 3. The denominator, we'll get x plus 2, x plus 6. Now we see the common factor of numerator and denominator is x plus 2. X plus 2 divides itself, it becomes 1. So then we have x plus 3 over x plus 6 left. So this is the simplest form for the original rational expression. Next one, we have y squared plus 3y minus 4. That can be factored as y plus 4, y minus 1. Y squared minus 6y plus 5. That can be factored as y minus 5, y minus 1. Then we see y minus 1 is a common factor. So I left with y plus 4 divided by y minus 5. Simplest form. Numerator, we can factor out x. So x times x plus 3. Denominator x squared plus 5x plus 6. We can factor as x plus 2, x plus 3. Then x plus 3 is a common factor of the numerators and denominators. So the result is x divided by x plus 2. Any question? So this requires our factoring skills. Let's see sometimes we make common mistakes. So 4 minus x, right, if we want to rewrite this, that's 4 minus x, which it can be written as negative x plus 4. And if we want to factor out negative sign, the inside the parentheses becomes x minus 4, because negative 1 times negative 4 is plus 4. But usually we don't bother to write this 1. We just leave negative sign in front. So 4 minus x is negative x minus 4, okay? Give me an example, 4 minus 10 is negative 10 minus 4, which is negative 6, right? It's negative 10 minus 4 is negative 6. Let's see here, numerator is 8 minus 5, denominator is 5 minus 8. And now we know 5 minus 8 is negative, parentheses 8 minus 5. So 1 is positive term, 1 is negative term, so that equals negative 1. Four minus x in the numerator, denominator is x minus 4 cubed. So we want to rewrite the numerator. Rewrite numerator as negative x minus 4. Then we see x minus 4 simplified with the denominator, one factor of the denominator, so we get a negative 1 over x minus 4 squared. If anyone has any question, feel free to stop me at any time. Let's see this one. (16 minus 4y). And denominator is y squared minus 16. So we want a y as a first term. So what do? We see we have negative 4y. So we can factor out the negative 4 for numerator. So negative 4y, then y becomes positive inside the parentheses. Then 16 divided by negative 4, that's negative 4. So we get a 1 minus 4. Denominator is the difference of two squares. So y plus 4 times y minus 4. So y minus 4 divided by y minus 4, that's 1. So what left is a negative 4 over y plus 4. Similarly, this one, x minus 7, then this is 7 minus x cubed, right? X minus 7 can be written as a negative 7 minus x. So 7 minus x simplifies one factors in the denominator, so we get negative 1 over 7 minus x squared. 7 minus x squared is the same as x minus 7 squared, right? Because it's squared, so the order inside does not matter. Okay, so this shows us 7 minus x squared, in the end we get 49 minus 14x plus x squared. X minus 7 squared, we also get positive x squared, positive 49, negative 14x. Just position a little bit changed. Right. Given an example, 10 minus 7 squared would be 3 squared, which is 9. 7 minus 10 squared would be negative 3 squared. Well, negative 3 times negative 3 is still positive 9. Let's see this one. So this one we have x minus 5, x minus 3 in the numerator. We have 5 minus x to the fourth power, 3 minus x to the first power. So because this is 5 minus x raised by 4, so we can switch 5 and negative x. So we can switch 5 minus x raised by 4 as x minus 5 raised by 4. Okay. But for 3 minus x, if we want to switch, we need to factor out the negative sign. So we can think x minus 3 divided by 3 minus x, those two factors equals a negative 1. It equals a negative 1. Then x minus 5, this one we can switch to be x minus 5. So simplify 1. So that's 1 over, negative 1 over x minus 5 cubed, right? Because x minus 3 divided by 3 minus x, that's negative. So negative 1 over x minus 5 cubed. So that's just to simplify rational expressions. We can multiply and divide rational expressions as well. So let's remember how to multiply two fractions. Which is multiply numerator with the numerator, denominator with the denominator. Then we look for common factors to simplify. In this case, there's none except 1. Usually we have a over b times c over d. That equals the ac times ad. Multiplying fractions connects to multiplying rational expressions. Let's see this one. We have this rational expression. We have this rational expression. So we still need to multiply numerator with the numerator, denominator with the denominator. Okay, and sometimes if we find the common factors in the numerator and denominator, then we simplify. But in this case, there's none. So we leave like that. Here we have x plus 2 divided by y plus 1, x minus 2 divided by y minus 1. So put them together, we see x plus 2 times x minus 2. That would be x squared minus 4. Denominator is y plus 1 minus y minus 1. Well, multiply together, then the y squared minus 1. So no more common factors. Let's see this example of x plus 2 times x minus 3 times 3x minus 2 cubed x plus 2. We just look for the same factors in the numerator and in the denominator, right? Because the numerator divides the denominator, get the quotient. So in this case, you see x plus 2 in the numerator, x plus 2 in the denominator. All the relationships are multiplication and division. we can just go ahead and simplify that to be 1. So we're left with x minus 3 divided by 3x plus 2. Well, 3x plus 2, here we have denominator. Here we have numerator, 3, exponent with 3. So simplify, so 3 minus 1 is 2. So that's, so this one divided by this one, so simplify to be 3x minus 2 squared. So in the end, we get x minus 3 times 3x minus 2 squared. Anyone has any questions? We want to factor, right? We want to put them in a factored form. Then we look for the common factor in the numerator and in the denominator. Because something divides itself becomes 1. In this case, x plus 2 divides x plus 2, that becomes 1. Let's see this. How do I get this away? This is so big. Let's see this one. Numerator will have 5p squared, quadratic. Denominator will have quadratic also, p squared minus 5p minus 36. Multiply, the numerator is p squared minus 16, difference of two squares, divided by 10p. Okay. So we want to factor p squared 5p minus 36. Think about, okay, the difference of two factors of 36 is 5. So we're thinking, okay, there has to be 4 and 9. But then how do we play those factors to get negative 5? We better choose negative 9, positive 4, right? Because negative 9, positive 4, negative 9 plus 4, that would be negative 5. So then p squared minus 16 is the difference of two squares. That can be factored as p minus 4, p plus 4. Then we see p plus 4 as a factor in the numerator, or p plus 4 as a factor in the denominator, so we cancel these two out. This 2 becomes 1. So we have 5p squared. Well, p squared can simplify 1p term. It's just 1, just p. So in the end, we have p of p minus 4 times 2 times p minus 9. Feel free to jump in, okay, when you have questions. Let's see this one. 28 minus 4b divided by 3b minus 3. We want to put those two in factor form. So obviously, we see the numerator has negative 4 as a common factor. Right, then we have b minus 7. So negative 7 times negative 4, that's positive 28. Then for 3b minus 3, we want to factor out 3. Right, so 3 times b minus 1. On this side, we have b squared plus ab minus 9. So we want to factor as b plus 9 times b minus 1. Then b squared minus 49, we just factor as b minus 7 and b plus 7. So then we cancel the common factors in the numerator and in the denominator. We see b minus 7 in the numerator and also in the denominator. Those two cancel to be 1. B minus 1 in the numerator, but b minus 1 in the denominator, so those two cancel out to be 1. So we're left with negative 4 over 3, b plus 9 divided by b plus 7. So similarly for those two, all right, you can You can read these examples later, or you can do this exercise on yourself. And similarly, we can divide, right? What is a division? Division is multiplication by its inverse, right? Let's say if we want to divide by 2, it's the same as multiply by 2/2. If we want to multiply 2/3, we will do the same process. Let's see this. So A over B divided by C over D. So what do we do first? We change division into multiplication. Then we flip the second numerator top down. So C is the numerator, then in the multiplication becomes the denominator. D is the denominator, in multiplication it becomes the numerator. So this is multiply, we get AD over BC. Let's see some examples. We have this x minus 3 divided by x plus 5 divided by x plus 1 divided by x minus 2. So what do? We change division into multiplication. We flip the second one around, the divisor around. So the numerator in the divisor now becomes the denominator. The denominator before now becomes the numerator. Then we multiply cross, right? If we have common factors, we would simplify. Here we don't have any common factors, so we just leave it like that. Next one, y minus 5 divided by 11 minus v divided by y squared minus 25, difference of two squares, divided by v minus 11. Well, what's the relationship between 11 minus v and v minus negative 11? The additive inverse. If we add those two, we get 0. So also means one is a negative of the other. So indeed, we want to rewrite 11 minus v as negative v minus 11. Then change division into multiplication, flip numerator and denominator. Then simplify, we get a negative 1 over y plus 5. Anyone has any question? So this is all similar, right? P squared minus 16, difference of two squares. We want to factor as p plus 4, p minus 4. P cubed minus 4p squared plus 16p. We want to factor out p first. So once we factor out p, the leftover inside the parentheses. And we probably can factor that if we could. Division, now let's change the division. Excuse me, let's change the division sign. So division now becomes the multiplication. Then we flip the numerator and denominator. Then we still have p plus 4 in the numerator and p plus 4 in the denominator. Those two cancel to be 1. Then we have p squared. We have p here. So simplify one term. We have 3p divided by p minus 4 and p squared minus 4p plus 16. Any questions? Very quiet. Let's see this one. 2p squared minus p minus 21. Right, this one can be factored. 2p minus 7, p plus 3. 5p divided by 5p plus 20 will factor out 5. We have p plus 4. Division, which needs to be multiplication. Then we flip the numerator and denominator. So p squared plus 8p plus 16, that's p plus 4 squared. 4p squared plus 7p plus 12, that cannot be simplified as a factor form. So we leave it like that. But here we have p plus 4, one term, we have p plus 4 squared, that can be simplified. Right? So that becomes 2p minus 7, p plus 3, p plus 4. divided by 5 times 4p squared plus 7p plus 12. Then no more can be cancelled, so we just leave like that. Well, let's see this example. We have a rational expression divided by a polynomial. We do the same thing, right? We change division into multiplication, then we take the inverse of this. Well, the denominator of this polynomial is 1. When we flip over, we just get 1 over 2x squared plus 20x plus 50, right? Then we multiply them. So we get x squared plus 3x minus 10, and denominator is 4x times 2x squared plus 20x plus 50. Now we try to find common factors. The numerator can be factored out as x plus 5, x minus 2. The denominator we can factor out 2 out, that becomes 8x. Then we have x squared left, so x squared can, then we have 10x, right? Then 25. X squared plus 10x plus 25 is a perfect square. It's x plus 5 squared. So one term cancel with the numerator x plus 5. So we're left with x minus 2 times 8x times x plus 5. If we want to put it vertically, this one will be 3 layers of division, right? Like this. You have 2/3 divided by 2. In the end, it's just 1/3. All right. If you're not good with this process, try a couple of times. So how do we multiply and divide rational functions? When we multiply numerator with the numerator, denominator with the denominator. When we divide, we flip the numerator, flip the sign division into multiplication. Then we switch the numerator and denominators. Let's go back to this one. Well, this one, the domain is as long as x is not 5, right? Or we use the interval notation sign. Oops. Get it from negative, so we know how to get rid of 5, right? Negative infinity up to 5, close parenthesis, union, open parenthesis, 5 up to infinity. So this one, 2x plus 3 cannot be 0. Right? That means x cannot be negative 3 over 2, which means x can be from negative infinity up to negative 3/2. Then union, open parenthesis, negative 3 over half up to positive infinity, close parenthesis. Well, what about how do we determine the quadratic? For linear one is easy. A linear equation is easy to solve. What about quadratics? Quadratics, if they put in a factored form, we do the same thing. Then we use zero property. So we split them. X minus 2 give us 2 as a solution. X plus 6 give us a negative 6. Well, this one is x squared minus 2x plus 1, which is x minus 1 squared, right? When does this equal to 0? Well, x minus 1 squared not equal to 0. We solve this, that means x not equal to 1, right? So the domain is x can be any number but 1. So how do we use the interval notation? We use negative infinity. I want to copy paste from the previous one. Oops. Right, that's a set notation, but we want to use interval notation. Interval notation. Okay, so we solve this, right? This is saying x cannot be 2, x cannot be, I should save that. So x cannot be 2 or -6. Okay. Using interval notation, that's from -infinity up to -6. Then from -6 up to 2, the union 2, comma, up to infinity. All right. So we want to use this interval notation to represent, to get rid of the values of 2 and -6 in the set. Next one, denominator is x squared minus 2x plus 1. So solve this, that's x not equal to 1. Again, using interval notation. Oops. Or from -infinity up to 1. Right? Union from 1 up to past infinity, because only 1 is not in the domain. For this one, we have 2, right? Because the denominator is a quadratic. We put in a factored form, we solve, we get x not equal to -5/2, or x not equal to 1. So using interval notation, that's a -infinity up to -5/2, union -5/2 up to 1, then union 1 up to past infinity, right? Split into 3 intervals to get rid of 3 values, 0, -5/2, and 1. Okay, similarly, we can multiply rational functions, we can divide rational functions. Let's see, we have these two functions. F is 28 minus 4x, linear. G is x squared minus 49, is quadratic. So we want to divide those two, right? F divided by G. Then difference of two squares in the numerator, that's x plus 7x minus 7. Then in the numerator, we see we could factor out -4, right? If we factor out -4, we would get x minus 7 right away. Then x minus 7 divides by x minus 7, it becomes, oh, I have here. So we're left with a -4 over x plus 7. Yeah. Okay, now, so we're doing division. So now f is defined as this. G is defined as this. So we want to find a division. We want to do f divided by g. What do we do? So first we put everything in the factored form. Oh, this is a multiplication axis. Shouldn't we do division? You can try on do division. Okay, this is try the multiplication. So when we do multiplication, we factor everything. Factor everything, we still do cross, right? So we say x plus 5 in the denominator and in the numerator, so that cancels. And then that's it. So we get x minus 10 times x minus 9 squared divided by x plus 6. X plus 6 raised by 3, right? Because this one, only these two factored out. The rest are staying. Anyone has any questions? Okay, that's it for today. Just, simple concept, right? Multiply and divide the rational expressions, and multiply and divide the rational functions, and also finding the domain of a rational function. Anyone has any question? If you have no question, you're fine. You can just go ahead to start to do your homework. All right. If you do have question, I'm here. Thank you. You're welcome. Thank you. Have a good day. Yeah. Have a good day. Okay, I'm going to stop recording.